So this is the formula sheet.
Wow, that's good. You're lucky. If you're given formulas, that's really, really, really good. So what I would do then is I would go back to your file and I'd go through all the theory in terms of where you've written a formula. And if the formula is on here, tick it and write a note what it's for. Okay. If you have formulas in your notes that you don't have on the formula sheets, then you've got to add it. Okay, then those ones that you add are the ones that you need to study and remember. Okay, so that's what you need to do is this for paper 1 and 2 or just paper 1? Okay, just find out about that, because to me this looks like paper 2 because you've got the integration here, unless they're testing it here, which we'll see. Okay. Alright, so this is the written one, yeah, and this is covering vectors, some trig, differentiation, double derivatives, and graphs. Let's just start the first question. Question 1 is focusing on what?
Okay, the diagram shows part of the graph of y equals a plus b sine x. State the values of the constants a and b.
Right, so exam technique, you write down the equation they've given you, which is that y equals a brackets b sine x. But all you've got to do is you've got to find a point here that you can use in order to solve. Right, this is out of 2 marks, so we're looking at the graph. So where does the graph start? Okay, the graph starts at 1 rather than 0, because remember, sine, if you remember the normal sine graph starts at 0, goes up, goes down, ends at 360. Remember that?
Yeah.
Okay, so I've got that picture in my mind. Why? Because I'm looking at sine. That's the exam technique. Okay, understand what they're giving you in the question. So you know that a sine graph looks like that. This graph in your question starts at 1. It doesn't start at 0. It starts at 1 and then goes up. That's 1. Goes up to 3 and then down to minus 1. Right, so the halfway point here would be 1 and minus 1. So 1 and minus 1. It goes up to 3. It starts at 0. No, I'm looking at the y-axis. Okay, because this is the y-axis.
Oh, so you start from, you don't look at this side, you just look at that side.
Well, the graph for sine starts where? At 0.
Oh, at 0.
So I'm looking at 0 and I'm looking at where does the graph start. In this particular question, it started at 1. It didn't start at 0. And then the graph went up to 3 and then down to minus 1. Do you see that? Okay, so when you look at the trig, if we go back and revise, I just want to go back to that general equation for the trig. The trig equations, 283. 283. Right, so when we covered the trig equations, there was a number in front of this, in front of the sine x, which is the b, that. And then, what did that do to the actual graph? It made more of them. Maybe your textbook's a bit better, your diagrams there are a bit better. I want to show you that diagram again, where when you have a number in front, yeah, you're going to change it. So there were two things, remember? Let me just write this down. Y equals sine x. That's a normal sine graph. Right, you can add a number in front here. You can add a number in front there. Two different numbers. So what does this do to the sine? Well, when you add a number in front here, it made two graphs instead of one. I don't know if you remember that. Okay, so that's what we're looking at here. It's just the, will be book one. It's just the knowledge relating to the trig graphs. So to revise that, yeah, the graphs of sine and tan, 151. Okay, so on page 151, they've given you those pictures. Here they. Right, what graph do I have there? Sine. Where does the graph start? Starts at 1. Starts at 0. Goes up to 1. Goes down to 0 through 180. Goes down to -1. Goes up to 360. Okay, then you had a graph where they put a number in front and that changed the period. Okay, this was the 90 minus the 180 minus. That was cos. That's tan. Sine cos tan. Okay, so that was the basics chapter where we had the trig. Trig graphs. Not in this book, so it'll be in that one. There, trig, that was looking at radians. Okay, radians you don't need. They're the form a sine x plus b cos x. This is on page 76. Okay, there you have the format for the a bracket sine x. And when you double it, this changes the amplitude. Okay, in other words, you've got 2 graphs. Okay, if you have a 2 outside, the 2 is going to change the answer. So for example, when I have sine 90, let's take the normal sine graph from this textbook, page 151. 151. Okay, let's take this graph there. Okay, so we know sine 90. On your calculator, type in sine 90. What does that give you? 1. Do you agree? Type in sine 0. What does that give you? It should give you 0. Okay, so now do you agree? If I've got sine 0, sine 0 is what? 0. Okay, because the normal sine graph starts, normal sine graph is there, starts there. We're looking at this graph. Where does this graph start?
1.
Yes, okay, if you look at your picture on the diagram, the question, the graph starts at 1. So this is going to be y equals 1 plus b sine x. Okay, so we already know what a is. A must be 1 because sine 0 is 0, then we've got a 1 there. Okay, so because y equals 1 plus sine 0b. Okay, anything times 0 is 0. So now we've got a. A is 1. Right, now we need to find b. Right, so I know that y equals 1 plus sine b. So this will be y equals 1 plus b. Then I'm going to put in sine Let's put sine 90 in, because sine 90 we know is what? 1. What is sine 90 in this question? Okay, we need to convert pi's again. So they've given you pi. So let's actually put it in.
So why are you doing that? Sine 90?
Because sine 90 is 1. Because of the basic graph, the one that you studied and remember. Okay, so the graph starts at 0, goes up to 1, goes down to 0, goes down to -1, goes back up to 0.
So you have to use 90 because it starts at 1?
No, the 1 is for what? The first point. So this point is what? 1. This point is what? 0. Okay, so when we substitute a 0 in, what should we get? Sine 0 is 0, right? But now, do I have 0 in this question? No, I have what? 1. Okay, because the question isn't the basic sine graph, because the basic sine graph y equals sine x is that picture over there. That's the basic sine graph. So they've added a and b to manipulate the shape of the graph. So the shape changes.
Okay, so what I was asking is why are you using the 90?
I'm using the 90 because what is sine 90 normally? 1. Right, so here on the normal graph, when the graph goes up from 0 to a point, the top point is at 90 degrees, which gives me 1. What is the top point in this question?
3.
Yes, and that occurs where?
At half pi.
Half pi. Okay, so they're using those radians again. Right, it doesn't matter what they use, it's fine. Okay, we've got half radians. So we know that a half radians, what is a half radian equal to? We need that conversion, that radian conversion. Let's convert it to a degree. Okay, you've got the formula, we wrote it down. You can either find it in your notes or we can go back and we can look for it here. This is book 1, yeah. Book 1 had the radians, as far as I can remember. Yeah, radian 284 was towards the end. 284 there. Right, there's the conversion for a radian. So let's convert the radians.
I don't know that this is radian because it's pi.
Yes, yeah. So see, that's the study, that's the background, that's the theory. Okay, so I know that pi radians equals 180. That's what I know. Okay, I want to know what half pi equals, question mark. Right, so obviously a half pi would be what? 90. Okay, a half pi would be a half 180, which would be a half pi is 90. 90. Right, so now I'm working with degrees. Degrees are easy to work with because you know sine 90 is 1. Okay, so I've done the conversion. I've used page 284 to do a conversion from radians to degrees. It's easier to work with degrees because you're familiar with it. Okay, so now I'll go back to my diagram. In this question, what did they give you? Well, they gave you this point. This point was a half radian, a half pi. A half pi is the same as 90 degrees. Okay, so when I substitute sine 90, I should get 1. Do I get 1? No, I get 3. Does that make sense? Okay, so that's what I'm showing here. Y equals, this is what I'm looking at now, because I know a half pi is sine 90. Right, so even if I didn't do that conversion, I knew what it was going to be. Why? Because I know my normal graph. I know my normal graph starts at 0, goes up to 1, goes down to 0, goes down to -1, goes back up to 0. Okay, so looking at this, I knew that that was going to be sine 90. So now I need to substitute in. What do I get when I put in 90 degrees here? I get a 3. So it'll be 3 equals 1 plus b sine 90. Sine 90 I know is 1. So it's b times 1. Alright, to solve for b. 3 equals 1 plus b. b equals 3 minus 1, which is 2. There's b. Now I've got A, now I've got B. The end. 2 marks. Okay, so A is 1, B is 2. Right, so if you wanted to know what did you need to know for this question, you needed to know that basic graph of sine. Okay, you need to know what it looks like, you need to know what the special angles are. Okay, sine 0 is 0, sine 90 is 1. Then you also had radians. So the radians would be just the conversion. Page 284, pi radians equals 180. I can convert radians to degrees. Okay, those would be the things that you would have to remember. And then you just have to apply your knowledge. Do you still need this?
Yes.
Okay.
So why did you change this back to 1? Sine 90.
Type in sine 90 in the calculator. What is sine 90?
Okay.
Yeah, sine 90 has a value. It has an amount, a figure. Okay, happy with that one? Great. Let's carry on. Next question. You've got it. What does it say? Question 2.
So that would be the final answer of y equals 1 plus 2.
No, the final answer would be A equals B equals, because they said solve for. See the question? Solve for the values of A
so
and B.
you wouldn't write it like that, eh?
You can write it like that if you want. That's fine. That's just more detail.
No, that is right.
And then just say A equals B equals. Now, they didn't ask for that specific formula, so you don't have to show it. If you want to show it, that's fine. As long as you've got A equals B equals and what they equal to, then that was what one was asking before.
Okay, express that in the form of that.
Okay, so let's write that down. What is it? 4x squared.
What's that?
2x plus, okay, you left out a plus a, close bracket squared, plus b. Okay, so that's the first one. Okay, so thoughts. Any idea what to do here?
No.
Right, so when you see a bracket with a number outside the bracket, you should be thinking completing the square, because that's what completing the square does. Completing the square adds brackets to get an expression that looks something like that. Okay, that was the very, very first thing we did in AS levels. Okay, so let's follow the process. Let's remember what to do in terms of completing the square. Right, so with completing the square, I need this. Let's highlight it. I need that. Okay, here they want to write it as a coefficient. Okay, so just to repeat the process, write all the terms containing x on the left-hand side and the constant on the right-hand side. Divide by the coefficient of x, add a half of the coefficient of x to both sides. factorize the left hand side, which is now a perfect square, and add the terms on the right hand side. Take the square root of both sides, and then you've got x on its own. Okay, so let's write that down. We write down this on this side. So 4x squared minus 12x. The question didn't give you any points, because this is on a graph. Okay, no, but they've got a part 2, because that'll probably be for part 2. Okay, so let's apply the completing the square. But I need to add, so plus, I need to add half of the coefficient of b. Okay, because that's bx. Okay, so add half b. So what's half of 12? Oh, before I actually add half of 12, I need to get x squared by itself. Let's add that step instead of doing 2 steps in one. Okay, so let's write down the 4 there. First step would be to obviously get rid of the 4. So divide by 4, divide by 4. Let's show the steps in between as well. So that'll be x squared minus 3x, and then we'll add the completing the square now. Okay, so let's delete this, and let's show it here, plus. Okay, plus. Completing the square says I need to add half the coefficient of b. b is the number in front of x.
Okay.
Okay, so this will be minus 3 over 2 squared, because that's adding half the coefficient of b. Right, so what do we get here? Let's see. We would get x squared and then we also need to add that to the other side. So then you'd have a negative brackets minus 3 over 2 squared. Okay, because this isn't equal to something. There's no equation here. That's why I'm just putting a negative and a positive. Okay, so
how did you get the 3 over 2? Minus 3 over 2?
I followed the completing the square steps. The completing the square step says you need to take half of the coefficient of b. Okay, what's half of minus 3? Minus 3 over 2.
Okay.
Okay, half the coefficient of b.
And then why did you say minus? Why did you add number minus?
Because completing the square normally has equal to a number, and then on the other side of the equation you would have shown the plus, so you would have added it to both sides. So now, do I have an equation? No. So I have to add and minus the minus 3 over 2 squared. Okay. So if I had to simplify this, this would be equal to x squared, so this would be minus here, 3 over 2, and that'll be squared. Okay, minus and the minus becomes, well, that squared will be positive, so negative 9 over 4. Okay, so this is completing the square. This is the final answer, but the final answer isn't in the right format because they don't want x on its own.
How did you get this bracket?
This, I'm just following the completing the square steps. That and that.
So you leave the rest out.
Become the bracket. Yes, this is the completing the square.
So what happens to that and that? Just leave it out.
It's part of completing the square because how do you FOIL this? FOIL this. If you multiply this out, if I multiply...
So what would I say to myself? Leave the rest out and just take the first and the second term?
Well, study the completing the square rules.
So what is the rule for this?
What is the rule for that? This becomes the brackets. Okay, because if I FOIL this out, have a look at this. 3/2 squared. Okay, let's FOIL this out. If I had to expand this, what is this going to be? This is going to be x squared minus 3/2. Okay, minus 3/2 plus, that'll be, if I square that, it'll be positive 9/4. 9/4. And then you'd have the minus 9/4 on the side. Okay, so this is what you've got here if you had to expand this out. Do you agree? If I expand this out. So now, what do I get here? What's negative 3/2 minus negative 3/2?
Minus 9/4.
Minus 3.
No.
Okay, that's the middle term. Right, so that's the completing the square as a rule, as a step. I'm just following it, but I'm applying it to this question. Okay, problem here is that they wanted a 2 here, they didn't want an x there. Do you see that? Okay, because we've got a 2 there. So we would make this over 2 and then get a common denominator and then times everything by 2. But that's going to take a bit longer to do. So I'm going to do another completing the square question, except I'm not going to divide by 4, I'm going to divide by 2, because then I'll get that as is.
So would you always take the first and the third term?
Yes.
You always do that in every instance?
Because that's the rule for completing the square.
Okay, that's what I'm saying.
Okay, so let's do this again, but let's get the 2 instead of the x. Okay, that's correct as it is, but obviously it's not in the right format, so I need to change the format. So to change the format, I'm going to do the exact same thing. 4x squared minus 12x. 4x squared minus 12x. Right, what am I going to do? I'm going to divide by 2 instead of 4, because I want 2x squared. Right, that's going to give me 2x squared minus 6x. That'll give me that. So see, now I've got the 2x there. Okay, so now if I had to complete the square here, I would do the exact same thing. So this would be, in terms of 2x squared, it will be x squared times x squared. You actually can't complete the square here because 2, unless you get root 2 and root 2, that actually doesn't help. Okay, so let's keep that then, and let's just do it the long way. I thought that would have been quicker. It's not going to be quicker. Okay. So let's just carry on with this and change the look of that expression. Okay, so this was the first part. This should have been a plus, not a minus. Plus. And then minus 9/4. Okay.
How did you get the 9/4?
Negative times a negative is a positive.
Yeah.
Minus 3/2 squared is that.
Okay.
Yeah, just the sign was wrong. Okay. Then obviously this is that. Alright, so now in terms of the notation, this x here needs a 2 in the front of it. So I need to change this. I need to make it look like the top part. Okay, so let's work with the brackets. Common denominator 2. So I'll have, if I have a common denominator, I need a 4 actually. Okay, 4. Right, so if I make it 4, then I need to times everything by 4, then I'll have 4x. No, let's times everything by 2. Let's write it down, and then let's just multiply. Let's show the step, the working. Okay, so x minus 3 all over 2 will be like that. Okay, 2x minus 3 all over 2. Close bracket, squared. Okay, that's the bracket, that's this. Okay, put it all over 2. Right, so now if I want to get rid of the 2, what must I do? Multiply this by 2, then I'll multiply everything else by 2. So I'm going to have bracket 2x minus 3 squared plus, if I times this by 2, I'm going to cancel, so 9 over 2 minus 9 over 2. Right, so your answer would be that. That would be the right format there. Okay, plus b. Right, so your 2x minus 3. So a would be minus 3, b would be plus 9 over 2.
Okay, so you went from this step here to there.
To this. I just showed that just so you understood what I'm doing.
Yeah,
Common
so
denominator times
then.
2.
So you got a common denominator.
Then times everything by 2. Yeah, make everything over 2. Because if I make everything over 2, I'm going to get the 2x plus a. Okay, what else did they ask for here? Can I just take the question and see? They said, express 4x squared minus 12x in the form. That's fine. Okay. Right, it's 2 marks, so it's not that long.
Please can you do this step again from here to there?
Okay, so
because it's a bit hard to see it because there's a lot going on that page.
okay, so what must I do here? Get a common denominator, right? What's the common denominator? 2. So if I put the x over 2, I need 2x at the top. Minus 3, close brackets, squared. Now what am I going to do? Times everything by 2. So times this by 2, 2 over 1, and then times everything else by 2 over 1, 2 over 1. Okay, because you had plus 9 over 4, 9 over 4, and minus 9 over 4. Right, so that's just the extra step to get that final answer. That's the final answer. Because I've just multiplied everything by 2. So if I multiply this by 2, 2 over 4, cancel. 2 over 4, cancel.
Where do you get the 9 over 4 from?
From the original question. From this. From here. From there. There's the whole thing.
So this times by 2 and over 2, it all cancels.
Yeah, so this whole thing becomes this whole thing. That's all. You only need to show those 2 steps.
So this I know, but it's to get to that final answer. So
yeah.
I'm not going to get to the final answer if I don't know how to get there. So this times 2 crosses out with that 2. What does this times 2 cross out with?
The 4.
But where is that?
There. Okay, times 2 over 2. Times 2, 9 over 4. So what do I do? Cancel the 2, 1.
I'm so confused because it's so
2.
messy. I don't know where everything is. Please can you start a new page because I really don't understand. Yeah. So there's actually 3 of them. Okay.
Next question.
So would you leave your answer like that? That's final answer.
Okay, here they say find the set of values of x satisfying an inequality. So this is your inequality question. Let's write down the inequality. 4x squared minus 12x greater than 7. Right, so now this is a good question. Why? Because I actually have something equal to a number. Okay, greater than 7. Right, so what must I do when I have a scenario like this? I need to basically
solve for the inequality.
Yes, so solve for x. That's what they said. Find the values of x. So 4x squared minus 12x minus 7 greater than 0. Alright, let's factorize that. Okay, that you should be able to do, factorize. Right, so you try factorize that. I'll factorize it as well, and then you can just look at mine just now, and you can see if you get the same thing. Okay, so split it into 2 brackets.
I think that's right. 3, 7, and 1.
This needs to give you that.
Yeah.
Because if I FOIL it out and I multiply everything else, that needs to give you that. Okay, so what do? I get the...
I did minus 3 and minus 4.
Minus 3 times minus 4 gives you plus 12.
Not minus 12.
Not minus 7.
So how do you do this cross method?
Factors of this and factors of that. Factors of 2, well, factors of 4. So 4 and 1, that didn't work. 2 and 2, that worked. Factors of 7, 1 and 7, that's it. I had 2 options. Option 1 doesn't work because I get 7 and 4. 7 and 4 gives me 11, not 12.
Minus 14 plus 2.
Yes, minus 14 plus 2 gives you the middle term.
So say 2 times 7 is minus 14, and 2 times 1 is minus 2. So which one's plus and which one's minus? How do you do it?
Well, the bigger number in the middle is what? Minus 12. So that means the 14 needs to be the minus and the 2 needs to be the plus. So the one will be plus and the one will be minus. So it'll be minus 7 and plus 1. Yeah, you need to go back and look at some of those other examples to practice. There's lots in the textbook, so you can do more of this if you want to get the not completing the square, the factorizing right. Because I see you're still struggling with it even after doing some practice. Just need to try get it right. Once you've got it right, then you've got it. That's the key. Yeah, because nowhere in these two textbooks did this come up. It was last year. Completing, factorizing. Factorizing is one of the most basic, let's say, trinomial things that you need to practice. Okay, so just become more familiar with it, so it'll be easier, and then you don't get stuck. Okay. All right. So what do I do next? This is equal to 0. So 2x minus 7 equals 0. This 2x plus 1 equals 0. Right, so then I've got 2x equals 7, x equals 7 over 2. 2x equals minus 1, x equals minus 1 over 2. Okay, I'm not finished yet because this is an inequality. What do I do with inequalities? You remember? I need to test them, right? I need to test the points. So let's do the test. Let's show it on the timeline. Okay, so 1, 2. Okay, so minus a half, 7 over 2. Okay, what's the question? Let's write down the question again. 4x squared minus 12x greater than 7. Okay, so let's test. Take any number less than negative a half. What number do you want to use?
Okay, what did you say?
Take any number smaller than minus a half. Which number do you want to use?
0.
0 is not less than negative a half.
Negative 1.
Okay, let's use minus 1. Right, so if I plug in minus 1 here, let's see what we get. Okay, so negative 1 squared is 1. 1 times 4 is 4. Negative times a negative is a positive, so that gives me plus 12. Greater than 7. 4 plus 12 is 16. Is 16 bigger than 7? Yes, it is. True. It's 4 plus 12. Right, so now let's take a number between negative a half and 7 over 2. What number's in between there that I can use that's easy to use?
Now we need to choose a number in the middle. 1.
1's not in the middle. Choose an easier number. 0. 0 is easy to substitute in. Let's plug it in. 0 squared is 0. 0 times 4 is 0. So I'll have 0 plus a negative 12 times 0 is 0. So 0 plus 0 greater than 7. Is 0 plus 0 greater than 7? No. 0 is not bigger than 7. False.
Can we just do it for the moment? Okay.
Right, what's the next thing? Any number bigger than 7 over 2. What number do you want to use?
1.
No, 1 I think is not bigger than 7 over 2. Let's go with a safe number. Let's go with 10. 10 should definitely be bigger than 7 over 2. Or even 100. You can use bigger numbers, it's up to you. 10. Okay, 10 squared is 100. 100 times 4 is 400. Plus, no, minus. 10 times 12 is 120. Greater than 7. 400 minus 120, 280. Is 280 bigger than 7? Definitely. True. Didn't you? Nice to see you.
Are you well?
Yes, fine, thanks.
You're doing well.
Yes.
On track.
On track. Well,
Almost done. Yeah.
starting the first maths paper today.
Okay.
I see a little bit of the basics are still a bit shaky, like factorizing that. So I think I'll give Whitney more exercises and see if she can try practice that. Yeah, because that's a bit of a worry. Yeah. Okay. But otherwise, I think it's okay. The first past paper, so once I think she gets the hang of it, it'll get better. Okay. So final answer, just put in the x's. X here, x there, and then put your symbols. Right. So there's the one answer, and there's the other answer. Okay. So final answer. The question said. It said evaluate or solve, hey? What did they say? Just reread it. Hence, find. See, find the values of x, satisfying it. So final answer, if I just write it neatly here, x less than negative a half, x greater than 7 over 2. That's the final answer. Okay, just after having done the test. That's what they wanted. 2 marks.
Okay, so just explain to me how you get that. So
From here, just put in the x there. From my test.
yeah, I was talking about the sign. How do you know about the sign?
Because negative 1 is smaller than a half. So x is on that side. If x is on that side, x is less than. Okay, so the signs will always be this way, and this way, and this way. Okay, because numbers start small on the left and they get bigger going right. Okay, so I'm just putting in the symbol. That symbol will stay the same as long as you are using the correct number line. Smaller numbers on the left, bigger numbers on the right. Okay, let's do another question. 3. Okay, so I'll do it and then you can check the approach. Okay, so if you read it, what do you think? What
Find the term independent
stands
of
out?
x in expansion of that. I do all the things.
Okay, so they want you to expand it. That's the key word. So expand means multiply out. Right, if something is independent, independent means it's standing on its own, separate from x. So if I have, let's do a basic working, 2x squared plus x plus 1. Which number is independent of x?
1.
Exactly. So what do they want? They want this. They want the constant after having expanded it all out. Right, so that's what we need to do. Okay, so let's start by writing down the question. I don't know if you remember the time we did one of those massive ones. Okay, it's one of those massive ones. Right, so what is the question? 4x. Is it, can you read it out? I can't see it so far. It's 4x what?
4x cubed plus 1 over 2x.
Okay, 1 over 2x to the 8. There we go. Right, so that's the question. Right, they want you to expand it. So what must I do? I need to expand it out, and I need to write how many of these? 8. So let's write down 8 of them. You can use that, they call it that binomial thing. That binomial thing might be a bit more tricky, but it could be quicker to use. I would rather just multiply it out normally, because anybody can do normal multiplication out, and that should be fine. Okay, so let's put, I'm going to need to group them into 4s. Okay, so I'll have 4 groups of 2 basically. Yeah, you'll see what I mean when I do this. Okay, let's write it down.
Just basically write 8 of those out.
Exactly. Yeah, but I want to show you, I'm going to group them in 2, so then it saves time, because then you don't have to write out everything so many times, because it can get massive. We saw one in the assignments.
So must I also write out 8, so you're going to show me something?
Yes, of course. You need the question before you do the answer, so show all the steps. I'm just writing down 8 of them, that's all I'm doing. 1 over 2x. How many do I have? 1, 2, 3, 4, 5, 6. I need 2 more. Okay, great. So now, the best way of doing this would be to group them in 2s, because have a look. If I multiply those 2 brackets together, whatever I get as an answer is going to be the same as those 2 brackets, the same as those 2 brackets, the same as those 2 brackets. So that's what I'm saying. To go about it quicker, do one working and then just replicate it 3 times. That's all. Okay, because then it's going to be easier than multiplying this into that, then this into that, then this into that, then this into that. Okay, so that's the better way of doing it if you're doing it this way. Right, so let's first work out what one of these are as an answer. Okay, so let's use that. Okay, so 4x to the 3 times 4x to the 3 is 16 x to the 6. Okay, then I multiply this, 4x to the 3 times 1 over 2x. If I'm multiplying this by that, I can cancel the 4 with the 2, so I'm left with 2. Then I've got x to the 3, and I can cancel that with the x, I'm left with x squared. Okay, then I need to multiply those two together. Alright, so same thing, 4 times 1 over 2x, so that'll be divide, so I'm going to have 4 cancelling with the 2, I'll be left with a 2, and then an x squared. Right, then the last bit is the end terms. Okay, so I've multiplied the first on the first, the outers with the outers, the inners with the inners, now the outers with the outers. Okay, so 1 over 2x times 1 over 2x is what? 1 over 4x squared. Okay, can I write this term down better? Yes, I can. I can add the two middle terms. So 16x to the 6 plus 4x squared plus 1 over 4x squared. Okay, there's the brackets. Right, so how many of them am I going to have? I'm going to have 1 here, 1 there, 1 there, and 1 there. I'll have 3 of them. So let's show 3 of them. Okay, so there's 2, I need 2 more. Okay, 1 more. Okay, so now I've got 1 there, 2 there, 3 there, 4 there. 1, 2, 3, 4. Brilliant. Right, so now what can I do now? Well, next step is to group them again to avoid having to do so many steps. Let's group those two together, because if I multiply that together once, I can just duplicate it because I've got it again here. Does it make sense?
Yeah.
Okay, so that saves time. Instead of multiplying one bracket by another bracket by another bracket. Okay, so let's do that. Now let's do the red. Okay, so on the new page, okay, so this is going to be a bit tricky. You need to just be careful with the multiplying out. Okay, so I'm going to first start with this term. 16x to the 6. Okay, this term, I'm going to multiply by all of these. 1, 2, 3 terms. Okay, so let's start with that. 16x to the 6 times 16x to 6. What is 16 times 16? Can you check on the calculator?
16x to the 3.
It's actually x to the 6. All of these are x to the 6. To the 6. To the 6. To the 6.
So 16 to the 6 times 16 to the 6?
No, 16 times 16 is what?
256.
256, great. So let's write that down. So this is 256 x to the 12. Okay, 6 plus 6 is 12. Okay, let's go back. 16x to the 6 times that. 16 times 4 is 64. 64x to the 8. Next, 16x to the 6 times this one. Okay, so if I'm multiplying 16x to the 6 by 1 over 4x squared, 16 cancels with 4, I'm left with 4. 6 cancels with 2, left with 4, so 4x to the 4. Okay, so now I've done that. Now I need to multiply this out. Multiply this, so the dots with the dots. Okay, so 4x squared times that into this. 4 times 16 is 64. X to the 2, x to the 6 gives you x to the 8. So 64 x to the 8. Next, this times that. 4 times 4 is 16, x squared times x squared is x to the 4. 16x to the 4. Right, and then that dot times that. So 4x squared times 1 over 4x squared. 4x squared over 4x squared is 1. Okay, now I need to multiply the x's. That x expanded times that, times that, times that. Right, so let's check. 1 over 4x squared times 16x to the 6. That can cancel. So 16 goes into 4 times. So it'll be 4x to the 4. 4x to the 4. 4x to the 4. Right, the next one. 1 over 4x squared times 4x squared is 1 plus 1. Then 1 over 4x squared times 1 over 4x squared is 1 over 16x to the 4. Okay, that's the brackets. Okay, so let's neaten that up. I've got 1 extra 12 there. So 2, 5, 6.
So don't you need 2 of these brackets? Yeah,
let's first make it smaller so it's easier to work with. Okay, so I can add those two together. 64 and 64 is 128. Right, I'm going to add these together, the squiggly line, this and this and this. Okay, so 4 plus 16 is 20, that's 24. 24x to the 4. What else? I'm left with the 1 plus a 1, which is 2. And I'm left with a 1 over 16 x to the 4. Okay, there we go, that's the brackets. Right, if I go back, how many of those do I have? I've got 1, I've got 2 of them, so I just need 2 brackets. So this times by itself.
So then it's just two of these.
Yeah, then multiply those two brackets out. X to the 4 plus 2 plus 1 over 16 x to the 4. Okay, so this is the last step. We need to be careful with the last step that we don't make a mess with the multiplying out, because we need to multiply everything out. So we need to put a long one. I'm going to change color.
So you would take this, 256 and you times it into that, like this.
Yes, you have to do the exact same thing.
Sure.
Yeah. Okay, so let's do that. Let's do the first one. So I'm going to underline it, multiply everything out, times that, times that, times that, times that, times that. Okay, let's see. Okay, I need the calculator to do this working. You can do it. Okay,
let me just do this.
256 times 256 is... this last step, you can do the whole thing. I want to do the whole thing just to show everything. But if you wanted to save time, all you had to do was look for what? They said in the question, look for the independent number, independent of x. So all I would do is look for the 2. And I would look for the 2 times the 2. Okay, but let's just complete the whole thing because we've started with it. So let's just finish it. Two, 5, 6 times 1, 2, 8 is 3, 2, 7, 6, 8. Now, so all of these terms with x's aren't actually important because you don't actually need them, you just need the constants. Yeah, so this was the exam, I would just skip this bit and I would just look at the constants. Okay, 256 times 6 times 24 is 614. Six, 1, 4, 4, x to the 16. Okay, then 256 times 2 is 512. Uh, 256 divided by 16 is 16. Okay, now I've done the first one. Okay, let's change color because this is going to be a massive one. Now I take this and I'm going to multiply that into all of them. Okay, so 128 times 256 is 32,000. 32. X to the 20. Next one, 128 times 128 is 16. 384. X to the 16. Okay, then plus 128 times 24 is 3072. X to the 12. Okay, then I've got 128 times 2 is 256. X to 8. And And then the last term here is 128 divided by 16 is 8. 8x to the 4. Right, so that one's done. Let's change color again. This multiplied out into all of them.
This is such a long side.
Yeah, but remember, you don't have to do all of this. I'm just showing it. You could skip all of these squared and you could just go to the constant. The constant times the constant gives you an answer, and that is the answer. Okay, I'm just showing you all the steps because this is what you would do to multiply it out. Okay, 256 times 24 is 614. 6144 actually. X to the 16. Okay, 128 times 24 is 3072. X to the 16. No, 120 times 24, x to the 12, not 16, 12. Okay. Right, then 24 times 24 is 576 plus 576. It'll be x to the 8. Okay, then 24 times 2 is 48, 48x to 4. And then that times that, so 24 divided by 16 is 14. No, it's 24, hey, it's black, yeah, it's 24 divided by 16, 3 over 2. 3 over 2, 3 over 2, that would cancel. Yeah, that would cancel. X to 4 would cancel. Yeah, so there's a constant. That constant is important. Okay, now we need to do the 2's. Okay, so multiply the 2 into all of them. Okay, so 2 times 256 is 512. X to the 12. Plus 2 times 128 is 256. X to the 8. 2 times 24 is 48. X to the 4. 2 times 2 is 4. That's an important one because I'm looking for constants. Okay, and then plus 1 over 8 x to the 4. Okay, last one, finally. Let's use one last color. Okay, so now I'm multiplying this into all of them. Okay, so 256 divided by 16 is 16. X to the 8. 16, so 128 divided by 16 is 8. 8 x to the 4. 24 divided by 16 is 3 over 2. Then plus 1 over 16 is 1 over 8. 1 over 8 to the x to the 4. the last term would be plus 1 over 16 times 16 is 256. X to the 4. Okay, finally, the end. Okay, we just need to add up all the constants. Don't worry about adding up all the other stuff, just add up the constants. Here's a constant here. That one we need to highlight. This one we need to highlight. And where's the other constant? There's a constant 4. With any other constants?
So then we don't need to do this whole big expansion.
No, you could. Well, you just needed to get to there.
Yeah.
Once you're there, you can just all the stuff with x's I can ignore. I'm just looking at that constants. That's all. So 4 of them.
But you said I wouldn't have to do this in the exam. So then what would I do?
You wouldn't have to do. You wouldn't have to do all of this. Showing 65,536 times x to 24 is pointless. Okay, so I would have said this times that gives me that. I wouldn't have written down that answer because I know I've got an x to 24. I've got x to something. So that one I would have ignored. I would have ignored. I would have ignored. I would have ignored. So I still would have done this mentally, but I wouldn't have written down these big numbers. Okay, I would have just looked for, well, the constants. So the 2 times 2, I would have said, yes, I need that. Okay, those two are the eliminations of these two. 24 x to the 4 times 1 over x. The x to the 4 cancels with the x to the 4. That's why you've got a constant. So I can see that, then I'll write that down. Okay. Alright, so the final answer would be, let's write down the final answer. 4 plus 3 over 2 plus 3 over 2 equals 7. That's the answer. That's what they wanted. Okay, so to answer that question, they said find the independent term of x. You would say independent term is 7. That's the constant. Okay. Right, very, very, very long question. Do you agree? Let's save those workings.
Keep it.